Hi, my name is Carla. I am a registered nurse, and today we're going to be working on a weight-based math calculation, but specifically we're going to be focusing today on the D over H times Q formula. So let's take a look at the screen. When we look at the screen, we see that we have a lot of information available. We have order, what is available, we have the patient's weight, and we have the question all within this problem set. So first let's write the formula D over H times Q, and let's discuss a little bit what this means. So D is my desired dose. This is what the doctor has ordered for me to prescribe the patient. I can find this information when I look here under order. And I can see that I have hydrocortisone 4,000 micrograms per kilogram. So this doctor has said that for every kilogram that my patient weighs, I have to give 4,000 micrograms. So he's not specifically telling me I have to give 4,000 micrograms. What he's saying is that I have to figure out how much this patient gets using this 4,000 microgram per kilogram formula. Now let's look at the H part. So when we're looking at what we have on hand, we need to look under the available section. So when we look under the available section, we see that we have hydrocortisone 150 milligram, and it comes in milliliters. So under the available, that will give us our H. The H is going to be 150 milligrams because remember, the H stands for the concentration of medication that we have on hand. So here we have 150 milligrams. And lastly, the Q portion is going to be the quantity it comes in. Usually your quantity will be in measurements of tablets, capsules, for milliliters. In this formula, we are going to use milliliters because that's what we have on hand. So before we can just go ahead and plug this information within our formula, first we're going to see that we have to figure out our D. So the D comes in a formula of 4,000 micrograms per kilogram. Remember, this isn't what we are giving. We need to figure out first how much this patient is getting based off of their weight. So for every 4,000 micrograms that my patient weighs, for every kilogram that my patient weighs, he is getting 4,000 micrograms. So let's figure out how much this patient weighs in kilograms first. So he weighs 198 pounds. So 198 pounds to kilograms. How do we do that? Well, we know that 1 kilogram is the same as 2.2 pounds. So let's divide 198 divided by 2.2, and that gives me 90 kilograms. So 90 kilograms. Now I can go ahead and figure out how much medication I need to give this patient based off of his weight. So what I do is I'm going to multiply 90 kilograms by 4,000 micrograms. If I look at this formula here, let's just go ahead and put the 90 kilograms over 1. That doesn't change its value, it stays the same. So when I use this formula, I can see that I can cancel out my kilograms because I have the same unit on the top in the numerator, and I have that same unit, that's kilograms, in the denominator. So I can go ahead and cancel this out. I'm left with micrograms. So let's go ahead and multiply 90 times 4,000. That gives me 360,000 micrograms. It seems like a big number. Don't panic yet. Sometimes these big numbers start to scare us off and we start thinking we're going in the wrong path. Trust the process. So 360,000 micrograms. What do we do with this information? Well, we know that that's our D. That's exactly how much this patient has to get based off of his weight. We figured out our D. This is our D. We can go ahead and plug that into our formula now. So let's do 360,000 micrograms. And we are going to put that over our H. What is our H again? We said that our H is 150 milligrams. That is the concentration of medication that we have on hand. 150 milligrams. Go ahead and ignore that little scribble there. Okay, so I have 150 milligrams available. And what quantity does that come in? Well, I have to go back to that available section. So my Q, my quantity, is milliliters. That is how much that 150 milligrams comes in. So it comes in milliliters, so it's going to be a liquid. So before I continue to solve this, I'm starting to see some discrepancies. I'm hoping you're seeing those too. The big discrepancy I'm seeing is that in the numerator, I have micrograms, and in the denominator, I have milligrams. I cannot divide units that do not match. So I need to convert either my 360,000 micrograms to milligrams, or I need to convert my 150 milligrams to micrograms. You can choose whichever one is easiest for you. Personally, I find that I am going to want to do this 360,000 micrograms to milligrams just so I can get a smaller number. Because I know that 1 milligram is the same as 1,000 micrograms. So I know I'm going to have to divide this 360,000 by 1,000. And that gives me 360. So 360 milligrams. Now my units, my milligrams and milligrams match. So I can go ahead and solve. And remember, when you have just milliliters mentioned, that's the same as saying 1 milliliter. So we have 360 milligrams divided by 150 milligrams times 1 milliliter. So let's go ahead and solve this. 360 divided by 150, that gives me 2.4 times 1 milliliter, so times 1, same answer, right? 2.4. And don't forget, we canceled out those milligrams, so we are left with milliliters only. So my answer is 2.4 milliliters. Now, before I assume that this is my final answer, I'm going to double check. So I'm going to go back to my problem set, and I'm going to make sure that they didn't say anything in my order about this having to be divided into several doses throughout the day, or that I have to give this dose many times throughout the day, you know, things like that. So I'm going to look at my order, and it says IV push stat 1 time. 1 time. So it's just a 1-time dose. So I don't have to worry about that. Now, another thing that you have to make sure that you take into account is that many times they are going to give you what value you need to round to. So what value are we rounding to? We are rounding to the nearest 10th. So let's look at my answer that I got. So in my 10th place, I have the 4. So I don't need to do any more rounding. It's already set to the 10th place. I don't need to round anymore. So 2.4 will be my final answer. And hopefully you got the same thing following along. Now, if you don't like this formula of the D over H times Q and you prefer a different method, I also have a video that shows you how to complete this same problem set using the dimensional analysis method. You can go ahead and click on that video here.